This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this video, we are going to see about the drinking water treatment. It is for the domestic purpose. So water, what we are drinking, should be free from undesirable odor, color and taste. It should also be free from the pathogenic bacteria, fungi and viruses. The water that we used should be free from turbidity and the pH of the water should be in the normal range. So for all these requirement, the water should be initially treated before using for the domestic purposes. So we know the different sources of water. So in this video we are going to see these sources of water, drinking water treatment, then screening, aeration and coagulation and flocculation process, sedimentation, then disinfection. So water treatment is the process of removing harmful impurities from the water to make it accessible to the public. The treated water can be used for irrigation purpose, drinking and many other purposes. You have different sources of waters like rivers, ponds, wells, reservoirs, flood. So drinking water should have no color, should be odorless, should not have any taste, pH preferably less than 8. TDS is total dissolved solids, is acceptable range. Then it should be free from toxic substances, free from bacteria and viruses, and also should be free from turbidity. The drinking water contains floating matter. So this floating matter is like paper, cloth, twigs, leaves, plastic, etc. Then it also contains suspended particles like sand, silt, etc. Then colloidal particles or fine particles, clay, etc. are present. Then microorganisms like bacteria, viruses, protozoa are present in the water. So there are various steps that are being followed to treat the water before domestic supply. The first step is the screening. So screening process is used to remove the floating matter like paper, leaves, plastic, logs, plants, etc. Then next followed by aeration. So aeration is processed by letting the air, that is oxygen, into the water so that the soluble gases like carbon dioxide, hydrogen sulfide are expelled by the aeration process. And next is the coagulation process. So coagulant chemicals are mixed with the water for further cleansing, that is alum, sodium aluminate, ferric chloride are example for the coagulants. So when it is treated, that is aluminum sulfate plus calcium bicarbonate that is present in the water can be removed by converting into calcium sulfate and carbon dioxide. Flocculation. So slow mixing brings the dispersed coagulant particles together to form a flock. So this flock, the fine colloidal particle negatively charged adheres to the flock, that is the positively charged, which grows bigger in size and becomes heavier. When it becomes heavier, when it is kept for few minutes, it will be settled down and it can be removed easily. And the next process is the sedimentation process. So the heavy flocks descends down due to gravity and settle at the bottom. So we have to keep it undisturbed for at least 6 hours in big tanks for the sedimentation process to take place. And next comes the filtration. The filtration process, it removes the left out particles, residual turbidity and few microorganisms. If activated carbon is used, it removes taste and odor from the water. So filtration, it consists of a filter bed which has the gravel, sand, charcoal or activated carbon, Then the water is made to pass through all these, and the water that is coming out, it has been removed from other impurities that is present. Even few bacteria and viruses will also be removed during this filtration process. Next is the disinfection. Disinfection, it destroys the pathogen, that is disease causing organisms. So you have different methods of the disinfections like chlorination, ozone treatment, ultraviolet rays treatment. So in the chlorination, what you do is bleaching powder, chloramine or liquid chlorine is being used. So chlorine with water gives hypochlorous acid plus hydrochloric acid. Ozone treatment, the ozone, it gives the oxygen plus nascent oxygen. So this nascent oxygen is a powerful disinfectant. It kills the various microorganisms that is present in the water. Ultraviolet rays. So the ultraviolet rays in the range of 254 nanometer ultraviolet light damage the RNA and DNA of the microorganisms, destroyed chemical contaminants, etc. Thank you.